So, welcome to the overview video for 1.1. This will be a single one-shot video that should explain all of the key ideas in this particular section. If you want to follow along in your book on OpenStax, you can find it in the course tab up. There's a materials tab up there that you can get into and see all this stuff. So we're just going to go ahead and begin today with a definition, as you do. And before you know what a function is, you need to know what a set is. So you all have seen sets before, but let's go ahead and do a definition right here. So a set is a collection of elements. So an example, a good example would be, let's do this. Let's do an example here. Let's do the set, let's call it, I don't know, this is boring, S. Capital S equals, and then we're going to put a set brace, which opens like you're making an E, and then you stop, you get lazy, you make a triangle, and then you finish making it. And let's put some elements in here, anything that you want. Let's do X, circle, triangle, and square. Which, for those of you following along at home, you may notice this set is the collection of PlayStation inputs. So as you look at this, instead of the PlayStation that you're trying to play, you'll notice that X, circle, triangle, and square are all called elements. These things here are called braces, and anything inside of a brace is a set. It has some stuff in it. That's what a set is. I don't need to belabor the point any further. So let's go back to another definition here. Let's talk about the first real definition that we need to know in this class, what a relation is. So a set, let me underline this for you, is a collection of elements. And let's talk about what a relation is. So a relation is a set of ordered pairs. Okay, neat. So we've already called this S. Okay, so we're going to come down here and we're going to do another example, this time also in green. Let's do another example. And we'll call this example 2. We can go back up here and call this example 1 if you'd like. So example 2, a relation is a set of ordered pairs. So let's get a set of ordered pairs. So let's call this one R, this set R for relation. It doesn't have to be called R. You could call it Q, you could call it capital A, you could call it capital P. I don't care, whatever you want to. You can make up a symbol. It's just like a variable, but it's capital letters. It needs to be a set of ordered pairs. So a set, okay, and then inside of it, we're going to put some ordered pairs. So let's go in here, and in this thing, let's put some ordered pairs. And let's do that in a different color because I can. So ordered pairs look like X, comma, Y. So let's just pick some numbers. 1, 7, 2, 9, and then just to throw off the pattern, -1, 14. Okay? And then we're going to end the brace here. So this is a relation. It is a set because it has the set braces, and it contains ordered pairs. And because it is a set of ordered pairs, by definition, we say this is a relation. Okay? Great, Mr. Bryant. Why do I need to know that? Well, it's because we're trying to build up towards what a function is, and at its core, a function is just a relation with the caveat, with something you got to watch out for. So we're going to look at this. But before we can do that, we need to do one more example so that I can talk about this. So let's do example 3 here. And we've already used S and R in this set of notes, so let's use P, capital P. So capital P is equal to, and then let's make this full of some ordered pairs. So let's say 2, 19. Let's do 7, 4. Let's do 2, 6. And let's open this up and do 12, -41. Whatever. I'm just making these numbers up. So we're going to end this. And now we've got P. So R was this set of ordered pairs. That was a relation. P is this set of ordered pairs, which is also a relation. You'll notice this has 3, this has 4. Whatever, who cares? So let's come up here, and in a completely different color, let's get a brand new definition going. So let's get a definition going. And I want to talk about the single most important definition in this class. Not the single most important formula in this class, or the single most important general form. We'll get to those later. But this is the single most important definition in the class, because math analysis, or the first part of pre-calculus, depending on how you're taking this, is predicated entirely on functional analysis. So if you can't analyze a function, you can't determine what a function's doing if you don't know what a function is. So let's look at this. So the definition of a function, this is the most important definition in the class. A function. So a function is a relation that does not repeat x values. That's all that the definition is. So a function is a relation that does not repeat x values. So let's go through this real quick. A function is a relation is a set, and a set is a collection of elements. Okay, cool. So this goes all the way back to the very beginning. So a function is a relation that does not repeat x values. Okay, we're going to have to remember something real quick because it's important. You have to know what an x value is, which one of these is x and which one of these is y. And let's just go up here and arbitrarily label these. Look here. This is x, this is x, this is x. The first entry in an ordered pair is the x, please. Please remember that. I'll go ahead and label all of these for you. And then we're going to come up here and we're going to label all of the y's. That is, unsurprisingly, the next part. So all of these things look like x, comma, y. If you need a way to remember this, you know the alphabet. I believe in you. X does come before y, and x comes before y in all of these as well. So the check to see if these are a function or not is look at each of the x values. We do not care about the y values, just the x values, and if they repeat anywhere in the relation, it is not a function. So let's look at r here. Let's see if r is a function. The values that you're looking for here are the x values, which are 1, 2, and -1. None of those are the same numbers, so this is a function. Okay? This is a function. Now, let's look at the x values in set P down here, which is a relation. Let's see if this is a function. 2, 7, 2, 12. Notice that this 2 and this 2 repeat. Therefore, this is not a function. Okay? So that's the only thing that you have to know in order to know a function. So a function is just a relation with a little extra caveat, like I said just a minute ago. So the caveat is it does not repeat x values. A caveat is something that you need to look out for. So a set is a collection of elements. A relation is a set of ordered pairs. A function is a relation that does not repeat x values. So really all that we're doing is we define what a set was, which is really loose. You can put anything in here you want. Then we made it more specific. It has to contain just ordered pairs. And then to talk about functions, the thing we're going to talk about this entire year, it's just a set that is a relation that doesn't repeat x values. That's all that it is. So a function is a relation that doesn't repeat x values. That's something that you're going to want to know. All right? So what we're going to do now is we're just going to scroll down here a bit, and we're going to talk about the next bit. So in an effort to try to keep these videos as short as humanly possible, I'm going to actually skip some of the stuff that your book goes over, but you should absolutely read in your book, and if you go over the Khan Academy videos, it's going to do a very good job at showing you these sort of blob graphs, as I call them, and you'll know these diagrams when you see them because it looks like a blob and another blob with some arrows going between parts of it. So if you go find that in your book and go ahead and read through that, it'll show you step by step very well what's going on. I've found that that's not actually a terribly useful thing for us to know going forward, and these are overview videos, which I'm only going to explain this once in this one particular very first one, but overview videos are meant to be an overview, not in depth. They're just meant to get you the core information as quickly as possible. So if you want to go find that, that's awesome. But what I want to talk about with you right now is some quick ways to see exactly what a function is given input and output. So let's talk about an actual function here. So let's say that you have a collection of inputs, whatever your inputs are going to be. And you're going to have a selection of outputs as well. And in between, there is a function. So you can think of a function like a really strange machine. So let's try and draw a machine here. Okay. And this machine is kind of like this. And what this machine does is we don't really understand what goes on in here. But we know that this machine is let's call this the doubling machine. The doubling machine. Or just the double machine. So this function's name is double. So what we're going to do is we're going to take a selection of inputs here. Let's say 3, 4, and 12. And we're going to feed them into the double machine and see what comes out. So let's feed in 3 and see what comes out. So I'm going to feed in 3. And it goes through the double machine. And it comes out like 6. Because that's what the double machine does. It takes whatever's put in and it doubles it. Let's look at 4 here. 4 goes in. And what comes out is, unsurprisingly, 8. And then finally, we're going to throw in 12. And what comes out is 24. All right? So what this machine does is double this. Now, this is a decent teaching tool, but it's not really all that good for actually looking at what the function does itself. So what this machine does is it takes your inputs, which are your x's, and it gives you your outputs, which are, in this case, what we did was we doubled x. So here's how you write this. You would say double, let me write this in teal, double, okay, double of your input x, okay, and the function equals, so now we just need to say mathematically what it is. Well, how do you double a number? Well, you take that number, whatever that number is, and in order to double it, you just multiply it by 2. So that's pretty simple. So what we're going to look at now is this is double of x. So how do we say what we did here? Well, what we'll say is we'll say double of x equals 2 times x. So double of 3 equals 6 is how we say that. So we say it like this. We say double, the double of our first input, 3, equals, well, it's just going to equal 2 times, and then in parentheses, 3. And we know that 2 times 3, just do the math, it's 6. So we say double of 3 equals 6. So notice, very importantly, that we replace this x with 3, so we replace this x with 3 in parentheses. And if you plug in your values for functions in parentheses, you will never have issues. All right, let's look at another example. So let's look at another example here. So let me divide this a bit. Let's say double of 4 here. So let's say double of 4. So double of 4 equals, and then let's do, this will be 2 times 4. And of course, 2 times 4 is 8. So double of 4 is 8. Now, this is getting annoying. I've already had to write the word double way more times than I ever wanted to. So what we actually end up doing is we don't write double. We just give the function a single name. In this case, it's a double function, so maybe D makes sense. So we could say, instead of saying this, we could say just D of 4 equals 2 times 4, which is 8. This is saying the exact same thing, but instead of saying double, we said D. But instead of using D, which isn't a great function name, we're just going to use F. Because mathematicians are nothing if not lazy. So f of 4, we'll say, is 2 times 4 is 8. So f of 4 is 8. All that we did was just rename our double function to f. So we could come back up here, and instead of writing double, we could just cross that out. Scribble, 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 scribble. You won't want to do this in your notes, but we'll just call it f instead. And that's just easier to refer to. It's much easier to say f of 4 than double of 4. And it's nowhere near as descriptive, but you don't need it to be descriptive because you have the function rule here. So finally, we would say that f of x for this function is 2x. This tells you everything you need to know. You don't need to name it the double function because you can look at it and say, well, it takes something and it doubles it. It multiplies it by 2. So that's how that ends up working. So I want to look at how to do specific problems. So we're going to scroll down, and that'll be the next thing that we'll look at. So let's go ahead and look at the fourth and final example in this overview. And let's evaluate a function. Let's say it's f of x equals x squared plus 3x minus 4, and we're going to do that at a few different points. So at 2, we're going to plug in 2 and see what happens. We're going to plug in the variable a and see what happens, and we're going to plug in the variable a plus h and see what happens. So it's a 3-part question, and we're going to look at each part separately. So if we call this 1 with a circle, 2 with a circle, and 3 with a circle, it should be pretty clear. So we're going to come down here and we're going to do 1 with a circle, and we're going to come back and we're going to say, okay, let's do f of, and then we need to plug in 2. So it's going to be f of, and we're going to plug in 2, and we're going to see what happens. So think about functions this way, and this is the most useful way that I can tell you to think of these. What does this function do? It takes in some input, in our case 2, in the general case x, and it does things. It squares the x, it multiplies the x by 3, and then it adds those two things together and subtracts 4. That's just order of operations. I did the exponents first, then the multiplications, then the additions and subtractions. If you can't remember the order of operations, I highly recommend you just go look up PEMDAS. Just do a quick Google search for that. I'll let you learn that one on your own. But here's what we're going to do. Instead of the x's, put parentheses, and otherwise copy and paste the entire thing. So x something squared plus 3 times something minus 4. What the function is this rule. This is what the machine does. It's pretty complicated. It's more complicated than the last thing that we went over. We've got 2 x's. So everywhere that there was an x, we put a parentheses. And then, what was in here? Well, a 2. So what goes in here? A 2, because that was the input. What goes in here? A 2, because it's the same input. There's an x there and an x there. X was the input. 2 was the input. So there's a 2 here and a 2 here. And then you just do the math. So all we're going to do is do the math. This equals, well, what is 2 squared? That's the exponents first. There are no parentheses. The only thing inside the parentheses are these numbers. So 2 squared is 4 plus 3 times 2, that's the multiplication. That's the next thing we do, is 6 minus 4 equals, and then we do the math. So 4 plus 6 is 10, minus 4 is 6. So we say then, to finish this off, we say, therefore, and this little symbol means therefore, just 3 dots like that, that means therefore. I'll let you annotate that in your notes. We say that f of 2, that's how we read this, f of 2 equals 6. Okay? Please do not make the elementary and very rookie mistake of saying f times 2. This is not a variable, it's a function name. We could have called it crazy quadratic if we wanted to. But we didn't. Instead, we called it f, like a smart person. So that's how you do this first one. Now, let's look at this second one here. The second one here wants you to go through and do f. Let's do it in orange. Actually, no, let's do it in teal, just so that it doesn't blend in with the above line. So let's do f of, and this time we're going to plug in a. And so we're going to do a, the thing that we're plugging in green, because we can. So we're going to do f of a, f of a equals, and then we're going to come through and do this. So we're just going to do the exact same thing. So the function rule, look back up here, says something squared plus 3 times something minus 4. So let's write that. Something squared plus 3 times something minus 4. So what is the thing that we're plugging in? Well, don't look up here. This was a previous example. Don't look up here. This was a previous example. What we're inputting is right here in the input. What are we putting in? A. We're putting in A. So instead of a 2, because we plugged in 2 in number 1, this time in number 2 we're plugging in A. We just plug in an A here and an A here. And then we do all the simplification that we can. So we're going to go ahead and do all the simplification that we can. A squared is just A squared. Plus 3 times A is just 3 times A minus 4. There are no like terms here anymore. We cannot finish these up anymore. So we just come out here and we say, therefore, f of A is just A squared plus 3A minus 4. All that we did was we just changed the variable. That should make sense. Up here we have f of an x, and then x's show up. Down here we have f of an a, and then a's show up. I told you up here what f was. It's something squared plus 3 times something minus 4. When you plug in a 2, you get 2 squared plus 3 times 2 minus 4. Here, if you do f of a, you get a squared plus 3 times a minus 4. It's the exact same thing. Whatever goes here, goes here. Now, let's do the very last of these examples, and you can move on to get the rest of your instruction from our boy Con. Now, let's look at this. Let's look now at f of, the last thing we were asked to do was a plus h. So this will be fun. F of a plus h. And let me put that in teal. F of a plus h. So the input on this one is in teal. Equals. Okay? And so it's the exact same thing. It's going to be something squared plus 3 times something minus 4. Look up here. It's f of x looks like something squared plus 3 times something minus 4. The x's mark the spot. What are we plugging in this time? A plus h. Don't think about it too hard. Just plug in a plus h. Plug in a plus h. Okay? So what we're going to have to do now is some hellacious math. So here's what we're going to do. We're going to write this as, this equals, okay? We're going to have to square this, and we're going to have to distribute this. So let's square this first. So what does it mean for something to be squared? It just means that it's that thing times itself. So we're going to say that this is just a plus h squared is nothing but a plus h times a plus h. And those of you following along and thinking back to your previous experience in Algebra 2 are going to immediately have flashbacks, but we're going to need to expand this, binomial expansion, or the FOIL method, if you can remember. And if you need to go look that up, how to do binomial expansion or the FOIL method, I invite you to Google that as well. But here's how we're going to do it. We're going to multiply the first terms times each other. So a times a is a squared. That's the first term. We're going to do the outer terms now. So a times h is a times h is just ah. So plus ah plus ah. And then we're going to do the inner terms. That's I. H times a. So plus, because they're both positive. Positive times a positive, positive. Plus h times a, which I'm going to write as a times h. It's the exact same thing. Plus, and then the last terms. H times h is h squared. Okay? That's that term right there. So this right here expanded into this. We still have the rest of it. Plus, we're going to just distribute this 3 in. 3a plus 3h. And then this minus 4 is just still hanging out here. Okay? And then the last step is we just put everything together the best that we can. So this equals a squared plus, well, we have 2 of these ah's. Okay? Great. So this is going to be 2 ah's. A number plus itself is just 2 times that number. Plus h squared plus 3a plus 3h minus 4. Now, we look through here really quickly and we notice, first off, we basically just dropped the parentheses and then combined these two things together. And that's all that was left to do. I see an a squared here. There are no more of those. I see ah's here. There are no more ah's. I see an h. I see an h squared. There are no more h squared terms. I see 3 of these a terms, or this 3a term. There are no more just a's by themselves. This one's squared, and this one has an h attached to it. Same thing with the h. This one's squared, and this one has an a attached to it, and then the minus 4 hangs out. So this is the answer. This is the entire thing. So we'll come over here, and we'll finally say, therefore, I'll do it in blue. Therefore, we'll say f of a plus h equals this hellacious nonsense. A squared plus 2ah plus h squared plus 3a plus 3h minus 4. All right, and that will do us for this video. So this should tell you everything that you need to know. It's a pretty solid introduction to everything that we're needing to do. And in the next overview for 1.2, we're going to talk about the domain and range. So go back over this, look over it, make sure that your notes are good, and if you have any questions, please bring them to class. Or send them to me in a